So once you're down to 5 or 6 designs, you can do concept scoring. Concept scoring is more involved because you actually have to do quantitative analysis of your particular design ideas. So to do the concept scoring matrix, we prepare the matrix. You need to read the chapter on concept selection before you do this and read the details about how to do it. It's important. We're going to rate the concepts. We'll use scores based on quantitative analysis, not just your gut feel this time. You'll rank the ideas, you'll combine and improve as you did last time, you'll select one or more concepts for each function, and you'll reflect and get the consensus of the team on which one you're going to continue with. So here's an example of a matrix that's a concept scoring matrix, not screening but scoring, because in this case scores are more quantitatively precise than screening numbers. It's not just 0, plus, and minus. In this case we have numbers, and you can define a scale from 1 to 5 or 1 to 10 or whatever scale you want. Notice we have another column in this one called weight. Do you remember when you were given your problem in class, your mini project 2 in class, you were given importance ratings on the criteria? The most important one, as I recall, was smokiness for the smoky stove, and it was a 10, and you had some others. You need to go back and look at those and pull those out to do this. So you'll put in, for the weights, you'll put in those numbers. They don't have to be percents, they can be any type of number. And then your job is to rate quantitatively each of these designs. In this case, we have now 4 of the syringe designs we've brought forward from the concept screening into concept scoring. And here are the numbers. So the ratings are on a 1 to 5 scale, 1 being the worst and 5 being the best. Ease of handling, reference master cylinder, they're using as a reference. It's a 3. Ease of use is a 3. Readability of settings is a 2. Dose metering accuracy is a 3. I should explain why they say reference. Reference means, it doesn't mean you put all zeros there, but it means it's about somewhere in the middle of the designs. So, but you have to estimate that, and it's not really critical that you do the reference idea. So go through all of these and evaluate them. Now, one way the book suggests to evaluate them is to make prototypes of all of these particular designs. And if you make prototypes of all the designs, you can actually run some tests. And the tests can be precise and accurate, hopefully, and you can actually get numbers from that. You can use those numbers then to give each of these designs a rating. In this case, in this class, for now, you aren't doing prototyping yet, so you should do some sort of evaluation, whether it's on paper or whether it's in your head. You should do some sort of evaluation and ranking that actually makes sense and is somewhat more than just quickly giving a gut feel for the design. You should think more deeply about the design to come up with the ratings. The weighted scores are the multiplication of the weights, which in this case are percents, times the rating. So if we take 0.05, which is 5%, times 3, we get 0.15. So I think you can see how that goes. So multiply them, get the weighted scores, add up the weighted scores, get a total score, and then you can pick out the winner. And the winner in this case is DF, which is 3.45. I think I have like a red circle around it. 3.45 is the number 1, and that is based upon the selection criteria and their weights. Notice we put the weights in, so the most important criteria have more weight on the design than the least important criteria. That's important for this. Here's an example, a concept scoring example for a spill-proof beverage holder. You see they can get pretty complicated. There are lots of criteria, and there are some sub-criteria and major criteria over on the left-hand side. So you can make these pretty extensive, and you see on the bottom the scores are pretty high. And they have ranked them at the bottom for the ideas. We have no idea what the ideas are in this case, but they've done a ranking. They picked the best one. So you see the weights are, for example, the first criterion is flexible use. It's been divided into 2 pieces, 2 sub-criteria, used in different locations and holds different beverages. So they've taken the weight of 20, which is flexible use, and divided it between different locations, which got 15 of the points, and holds different beverages, has 5 points. So you can get very detailed and do subdivisions of criteria on this. And then they did the total score at the bottom, and they also included manufacturing ease in this case. That's something that you might want to include in your stove design or your design for your final project for the semester is manufacturing. That's something we didn't consider. That's something the user doesn't care about, but you care about it because you're the designer. So you might want to include that. So in summary, you rank the solutions for each function. You keep only the top ranked solutions, and that's how you reduce your concept combination table in size. You do concept screening, then you rate the concepts, then you do concept scoring, you sum the weighted scores, and you find a winner.